Lesson 6.1. Our objective is to solve a system of equations by graphing. System of linear equations. A set of two equations with two variables. Solution of a system of linear equations. An ordered pair that is a solution to both equations. For this lesson, we're solving systems of equations by graphing. However, before we actually start to solve the equations by graphing, we're going to decide whether the ordered pair, the given ordered pair, is a solution to the system. And if you look at my first one, I have my two equations. I have for the first equation, I have y equals 2x minus 3. And for my second equation, I have y equals 4x plus 1. And we're going to check to see if negative 2, negative 7 satisfies this system. Now, by definition, a solution of a system of equations is an ordered pair such that it satisfies both equations when substituted into the equations, okay? So all we're going to do is check to see if it makes a true statement for both. The negative 2 represents my x value. The negative 7 represents my y value. Okay, so for my first equation, I'm going to substitute the y with a negative 7 and the x with a negative 2. So this will become negative 7 equals 2 times negative 2 minus 3. So this becomes negative 7 equals 2 times negative 2 is negative 4. Bring down the minus 3. And negative 4 minus 3 is indeed negative 7. So that checks out. Now, however, in order for it to be a solution to the system, it has to check out in both equations. So I must check it in the second equation as well. So my second equation, I had y equals 4x plus 1. So I'll substitute the y with negative 7. Excuse me, let me fix this. That should be an equal sign. Negative 7 equals 4 times, I'll replace this with the negative 2 plus 1. Now if it is indeed a solution, the left side should equal the right side. 4 times negative 2 is negative 8. Bring down my plus 1, and that gives me negative 8 plus 1 is indeed negative 7. So that checks out. So since that ordered pair worked in both equations, that lets me know that, okay, it is indeed a solution. So I'm just going to put yes. It is a solution. So let's do the same thing with the next one. On the next one, I have my two equations. I have my equation 1, equation 2. I have my ordered pair 4, 1. The 4 represents the x value. The y represents 1. 1 represents y, excuse me. So in equation 1, I'm just going to simply make that substitution. So equation 1 is x plus 2y equals 6. So after I substitute the values, it will become 4 plus 2 times 1 equals 6. Okay? Now on the left side, this will become 4 plus 2 times 1 is 2. And then 4 plus 2 is indeed 6. So that checks out for the first one. Now, a common mistake that students make, they'll check the first one. If it works, they'll stop. You have to check both because it may work in one and not the other. So my second equation is 3x plus y equals 11. So this will become, when I make my substitution, 3 times 4 plus 1 equals 11. 3 times 4 is 12 plus 1 equals 11. Well, 12 plus 1 is 13. So that doesn't check out. That does not check out. So since the left side does not equal the right side, we know that this ordered pair 4, 1 is not a solution. So I'm going to say no. It is not a solution. Okay, now for my last one, I'm going to move this up just a smidge so we can see a little better. We're doing the exact same thing. I have my system, my first equation. I have x minus 2y is equal to a negative 1. And for my second equation, I have negative 3x plus 4y equals negative 1. We're checking to see if the ordered pair 3, 2 is a solution to the system, okay? So for my first equation, that's going to become 3 minus 2 times 2 should equal negative 1. So on the left, this is going to give me 3. Negative 2 times 2 is negative 4 equals negative 1. Well, negative 1 does equal negative 1. 3 minus 4 is negative 1, so that checks out. Now don't forget, if you check the first one, you have to also check the second equation. It has to be true statements in both. It has to make a true statement in both equations. So for my second equation, it becomes negative 3 times 3 plus 4 times 2 should equal negative 1. Negative 3 times 3 is negative 9, and 4 times 2 is 8. Well, negative 9 plus 8 is negative 1, so this checks out as well. So since it worked in both equations, that lets me know that this ordered pair 3, 2 is a solution. So I'm going to say yes. Now we're ready to actually start solving the equations by graphing. But before we do so, we need to go over a few of the guidelines for solving a system by graphing.
Graph both equations in the same coordinate plane. Number 2, identify the point at which the two lines intersect. The point of intersection is the solution. And number 3, check the solution by substituting it back into both equations.
Okay, now we're actually ready to solve the equations by graphing. And from the guidelines, you know that what we're going to do is we're going to graph both equations in the same coordinate plane, and the point of intersection is our solution. If you're still having trouble with graphing, we've covered graphing in a previous lesson. You may want to go back and review that lesson. Okay, so I have my two equations. I have equation 1 and equation 2. From equation 1, I'm going to graph both equations by using the y-intercept and the slope. I'll get my y-intercept, and from equation 1, I know that my y-intercept is 3. My y-intercept is 3, and I need my slope, and my slope is a negative 1/4. Okay, so I'll use those 2 points. I'll use those two pieces of information to graph my first line. So I know to graph my y-intercept, that first point I'll move up to on the y-axis to 3. That's my first point. And then my slope is a negative 1/4, so I'll move down 1 and to the right 4 spaces. I think I'll make a couple of more lines, or I could move up 1 and to the left 1, 2, 3, 4 spaces. I'm going to make a few more and one more point, excuse me. I'm making more points because it's going to be difficult for me to draw my line, and I'm trying to get it as straight as possible. So I'll draw this line. However, now when you are graphing this, please use a straight edge. Use a ruler. If you don't have a ruler, you can use your ID card or something to get a good straight line. Okay, so now that's my first one. So now for line 2, my y-intercept here is negative 4. So this is going to be negative 4, and my slope is a positive 3/2. Okay, so now I'll graph my next one. So the y-intercept on the y-axis, I'll go down to negative 4. 1, 2, 3, 4. That's my first point.
Then I'll use my slope. I'll move up 3 units, 1, 2, 3, and to the right 2, 1, 2. I'll make another point up, 1, 2, 3, and over 1, 2. And here you can already see what my point of intersection is going to be. And I'll draw my line through. Try to go as straight as I can. Okay. Now where the two lines intersect, now I'm off just a smidge because I was not able to use a straight edge. That's my solution. So now in order to write what the solution is, I just need to get this ordered pair. So in order to get to this point, I'd move over 1, 2, 3, 4 units and up 1, 2. So that means that the solution here is 4, 2. Now, I'm not going to check each one of these for this example. However, I'm going to check this one. I have that the solution is 4, 2. Now I'm going to substitute that back into both equations. For my first one, when I make the substitution, it would become 2 equals a negative 1/4 times 4 plus 3. Okay? Here this cancels out and just becomes a negative 1. So this is 2 equals negative 1 plus 3. Well, negative 1 plus 3 is 2, so it checks out in the first one. So now I'll need to check it out in the second equation. So this would become 2 equals 3 over 2 times 4 minus 4. 3 over 2 times 4 is 6. Then bring down the minus 4. 6 minus 4 is 2. So it checks out in the second one as well. So that lets me know that I have the correct solution. Okay? Now let's look at the next one. We'll try that next one together, and then I want you to try a couple of them on your own. Get my pens back here. Okay, I have my two equations. I have x minus 3y equals 3 and 4x minus 3y equals a negative 6. This time they're not in slope-intercept form, so I'll have to put them in slope-intercept form first. So for the first one, I have the equation x minus 3y equals 3. I'll subtract this x from both sides. That leaves me with a negative 3y equals a negative x plus 3. Then I'll divide everything by negative 3. Okay, so that leaves me with y equals. Now when I get here to this x over 3, this negative x over negative 3, that's the same as 1/3 x. And then positive 3 divided by negative 3 is negative 1. So here my y-intercept is negative 1, and my slope is 1 over 3. So now I'm ready to graph this line. So for my first point on the y-axis, I'll go down to negative 1. That's my first point. Now my slope is a positive 1/3, so I'll move up 1 and over 1, 2, 3 units to the right. I believe I'll put a couple more points up 1 over 1, 2, 3. Now if I wanted to move down, I'd move down and to the left 1, 2, 3. I think I'll do one more. Down 1 over 1, 2, 3. It's another point. Now I'll draw my line through, straight as possible. Okay. Let me move this up just a smidge. Okay, so for my second equation, equation 2, I have 4x minus 3y
equals negative 6. I'll put this in slope-intercept form. Subtract 4x from both sides. That leaves me with a negative 3y equals a negative 4x minus 6. Divide everything by negative 3. Now that leaves me with y equals negative 4 divided by negative 3 is a positive 4 over 3. And negative 6 divided by a negative 3 is a positive 2, so plus 2. So now from here I can take my y-intercept, which is 2, and my slope, which is going to be a positive 4 over 3. Okay, now I can graph this line. On my y-axis, I'll move up to 2, 1, 2 units, and that's my first point. My slope is a positive 4 over 3, so I'll move up 1, 2, 3, 4 units and over 1, 2, 3. Now, I see if I keep moving up and over, I'm not going to intersect with the other line on this coordinate plane. So I'll move down, I think I'll move down 1, 2, 3, 4 units and over 1, 2, 3. Now I run into the point of intersection, and I can draw my little line through. Okay, point of intersection is here, which is my solution. That's my solution. And this point is 1, 2, 3, negative 3, and I go down 2 units. So my solution is negative 3, negative 2. Now what I want you to do, I want you to pause the video, work the other two problems on your own, then restart the video to make sure that you have the correct answers. Okay, if you've restarted the video, that means you're ready to check your answers. Let's go ahead and take a look at the next one. The system that we have is 4x plus y equals 4, and x plus 2y equals a negative 6 on my two equations. The two equations, what I'm going to do is I'm going to go ahead and put them in slope-intercept form so I can graph them. Okay, so for the first one, I'm going to subtract this 4x from both sides. That's going to leave me with y equals negative 4x plus 4. Okay, my y-intercept in this case is 4, and my slope is negative 4. But I'm going to write it as a fraction, so I'm going to put it as negative 4 over 1. For the second equation, which was x plus 2y equals negative 6, I'm going to do the same thing and put it in slope-intercept form. My x's cancel out on the left. That leaves me with 2y equals negative x minus 6. Then I'll divide everything by 2. Okay, that leaves me with, now negative x over 2 is the same as a negative 1/2 x, and negative 6 over 2 is negative 3. So my final equation is y equals a negative 1/2 x minus 3. My y-intercept in this case is negative 3, and my slope is a negative 1/2, negative 1 over 2. Okay, so now I'm ready to graph. Going back to my first equation, the y-intercept was 4. So on my y-axis, I move up 1, 2, 3, 4 units, and that's where I'll put my first point. Then my slope was a negative 4. So from the y-intercept, I'll move down 1, 2, 3, 4 units, and to the right 1 unit. believe I'll move down 4 additional units. I'll put another point. So I'm going to move down 4 more units. 1, 2, 3, 4. And to the right, one more point. Now I'll try to draw my line through as straight as possible. Okay, it's my first equation that I graph. The second one, my y-intercept is -3. So on the y-axis, I move down 3 units, and I put a point on -3. Then my slope is -1/2. So I'm going to move down 1 unit, and then to the right 1, 2 units. And you see, I already see where I'm going to intersect. I've already hit the point of intersection for the two lines. And then I'll just draw my little line through, being as careful as possible. Let me fix that. I think I can get a little bit straighter than that. That's a little better. And you be sure that you are using a ruler when you do this. And I see here's my solution. Now I need to identify, well, what is this point? So in order to get to this point on the x-axis, I would move over 1, 2 units, and then I'd move down 1, 2, 3, 4 units. So that means that my solution is going to be 2, -4. Now if you've made a mistake, make sure you go back and correct yourself. So when you're looking at your notes, you have the correct answer and the correct procedure. Okay? Let's move on down to the last one, so you can check your answer on this one. Now this one kind of worked out pretty good for us because both equations are already in slope-intercept form. So that's just one step we don't have to worry about doing. My first equation is y equals 6x minus 2. My y-intercept in this case is -2. And my slope is 6. Once again, I'm going to write it as a fraction. I'll put 6/1. So now we're clear about what's rise and what's run. Okay? For the second equation, the equation is y equals x plus 3. My y-intercept in this case is 3. And my slope is 1. Remember, when you don't see a number in front of the coefficient, that means that it's 1. But once again, I'm going to write that as a fraction so I can identify the rise and the run. Now I'm ready to graph. For the first equation, my y-intercept was -2. So on my y-axis, I want to move down 1, 2 units on the y-axis and put a point at -2. Then my slope was 6. So I'll move up 1, 2, 3, 4, 5, 6 units, and to the right 1 unit. And I'll put another point. Okay? Now I'll try to be real careful and draw my line through these 2 points. Try to get it as straight as possible. I think I can do a little bit better than that. I'll draw my line through, trying to be real careful. Okay? So for my next equation, my y-intercept was 3. So on the y-axis, I'll move up 1, 2, 3 units, and I'll put my point. Then I'll use my slope. Slope was just 1/1. So I'll move up 1 unit and to the right 1 unit. And the two lines have already intersect. And I'll just draw myself my second line through the 2 points. And their point of intersection is the solution. Now I'm writing this so you can clearly see where the solution is. Now we need to identify, well, what is this point? To get to this point on the x-axis from the origin, I would move over 1 unit, and then I would move up 1, 2, 3, 4 units. So that means that my solution, I moved over 1 unit on the x-axis, and then I went up on the y-axis 4 units. So that means that my solution is 1, 4.